Happy Friday, everyone. Today is September 20th, and this is episode 51 of Get Your Tech On, our show on all things DOCSIS. I'm Brady Volpe, founder of Nimble This and the Volpe Firm. With us today is John Downey, who promises to strike a pose for anyone who comes up to him at this year's Cable Tech Expo. Also with us is Rich Maroney, product line manager of coaxial cable with PPC. So, guys, great to have you with us on our show. Good to see you. First, to start off, John, you're new to our show. Rich, you're new to our show. Good to have you with us. Thanks for joining.
Yeah, great to be here. Yeah, thank you.
Rich, where are you from? Tell us a little bit about yourself.
Yeah, so in Syracuse, New York, or PPC headquarters up here in upstate New York. A little bit about my background is background in mechanical engineering. I've been working with PPC for about 3 or so years now. Started in the drop connector product line, worked on a lot of the different F connectors we have here. Also got some great experience with our construction hardware, hardline connectors, and a lot of our in-house test lab. And after doing engineering for about 2 years, moved over to our product management side of things, and have been now managing our coaxial cable line here at PPC.
All right, excellent. Thank you. John, so I wasn't sure you were going to be on the show today. Glad to have you with us. I guess you're doing a little traveling.
Yep. I took a little vacation at the beach.
Awesome.
Enjoy it before next hurricane comes through.
Yeah. So I mean, your beach house was okay with the last, I think it was Dorian that came through up the East Coast?
Yeah. Wilmington didn't get hit really at all. So we got lucky. So glad to be back, and hopefully my connection's not too bad or I don't get knocked offline.
Yeah, well, it's good for us, and your connection's good because we do get a lot of complaints, man. You get some fiber out your way. So today's show, we're going to be talking about back to basics on connectors. Before we get into that, I want to give a couple shout outs. One is to the SCTE North Country chapter. I was up there last week and gave a presentation on DOCSIS 3.1. So everyone up there was absolutely fantastic. So great chapter, and had a good time up there in the morning. So thanks for everyone's hospitality there. Also want to give a shout out to Broadband Library Magazine. The latest issue that I have an article in there I want to plug, which is High Latency DOCSIS is Killing You. It's also on their online edition, broadbandlibrary.com, so I recommend that you read it. I've been doing actually a lot of talking with operators lately, and particularly the operators that have overbuild with fiber. They are really seeing gamers who are really choosing to maybe go to fiber because the latency may not be higher or maybe the same as DOCSIS, but at least it's more stable. Because DOCSIS, we can really see the latency going up and down, and it's really critical for first-person shooter games, live-action games, stuff like that. And the demographics for gamers, people who invest money, it's not really 11-year-olds anymore. It's people that are in their 20s, 30s, 40s even are spending a lot of time, and they're the decision makers of what internet they will choose between, such as like fiber or coax. And a lot of times, if the latency is lower, that will make them choose fiber over coax. So having a lot of discussions with operators right now over that, and that's something, latency we were focused on originally was 5G, and now it's gaming actually seems to be the more killer opportunity with gaming. And if the latency is bad, you will die in a live action game. So it's pretty interesting stuff, and the demographics are amazing on it. So recommend you read my article and maybe talk on a later opportunity on that.
So you say sometimes it's not really the latency per se, but the changing latency, which would be jitter.
Yeah,
so the inconsistency.
Exactly. Yeah. For instance, I've seen on some fiber networks where the latency is 75 milliseconds, but at least it's a stable 75 milliseconds, so you can kind of predict and shoot ahead of the guy that's running that you're trying to shoot. Whereas if that latency is jumping from 75 to 15 to 100, which we see a lot in the DOCSIS networks, that can be much more problematic because you just can't predict it of what's going to happen. So I like to steady latency as a gamer myself over unpredictable latency.
Yeah.
So back onto the topic. So from a P&M standpoint, I spend a lot of time in the field with customers, and we identify homes that have, they're identified as a red subscriber because they're having issues. And a lot of times we get there and we find out there's bad connectors on the home. And it could be one of these crimp-on type connectors that maybe a customer got at Radio Shack and did their own wiring. A lot of times, though, we find out it's a nice compression type connector. And that connector was improperly terminated. And sometimes it's easy to see that, it was not properly terminated, wasn't properly crimped, wasn't properly put on well. Many times we see connectors where it's just not easy to visibly see why that connector was put on incorrectly. And so that's why we ask Rich to come on today from PPC and maybe help us understand what some of those issues are that we're seeing. Why is it connector is not always a good connector, even though it looks like it's put on there well. And so, Rich, I'll open up to you, and maybe you can help now start navigating this conversation into why is it a connector is not always connectorized properly, and why does that cause micro reflections? Why does that cause issues with the modems and things like that?
Yeah, absolutely, and that's a great transition in. Is essentially, step one is having the right equipment for the job there. Of having, make sure you have a good source of your cable, using adequate connectors, not a old school crimp or hex crimps or anything along those lines. And then even in addition to that is a lot of the prep tools. So that is essentially setting yourself up for success, making sure you have sharp blades on your prep tools, making sure your compression tool isn't worn out or anything like that, and nice clean cut on the cable. So all those basics really set the framework for a good connector installation. And with that, we, as many people have seen, is that those poor connections can kind of wreak havoc on the entire system there. So we've done a lot of field research, myself included, spend a lot of time out in the field, get to work directly with, technicians and the subscribers and see, what's truly causing these issues. And through, a lot of those field write-outs, we've actually been able to quantify different types of issues and actually start to rank them and see what are the most common issues and how those then affect the system. So from our side of things, the number one thing we actually see as a craft error is that the connector is not properly tightened onto the port. It's seem like could be the simplest of things, kind of the final step of, just make sure the connector is tightened on there. But there's a lot of other factors that can happen. Maybe a subscriber were to move a TV or something like that in the room. So a lot of different variables could occur.
Yeah, so there you're just talking about loose connectors, right? I mean, the connector needs to be tight.
And,
however, I think when we talk about loose connectors, we also then sometimes struggle into people who may over tighten the connector. So do you recommend, how do we know what is too tight and what is too loose when we get to tightening connectors?
Absolutely, yeah. So whenever using a device within the house, like a set-top box or a modem, is for that, those ones will be finger tight onto a device. However, when you're at wall plates or maybe even out at a tap in the pedal stool or out on the line, those ones you always, at best, want to make sure you use a torque wrench, 30 inch-pounds, make sure it snaps there, and ensure that is adequately tightened onto the port. And the other side, like you mentioned, is tightening it too much, is that tightening it, well beyond what it's meant to, and exceeding that torque limit, you could potentially either damage the port, damage the connector, and that's something you might not even be able to see at first. And taking that little bit extra step to make sure it's tight, we go a little bit too far in there. So that's where, from our side of things, recommend using a torque wrench, and that you can properly secure the connector to the device it's going to.
Cool.
Yeah.
So, do you guys provide torque wrenches, or do you see that they're actually used in the field? I've never really seen a tech using a torque wrench before. So.
So some of those we'll provide within our Tools for Life program. Is essentially when a customer purchases exclusively all of their cable and connectors through us, we do provide them with a compression tool, prep tool with any blades, and then on occasion we will distribute some torque wrenches. A lot of techs will, some will use those, some will just go with, finger tight and a quarter turn with the wrench after that. Everyone's got their own preference there, but ideal state is a torque wrench. So.
Okay.
Yeah.
Cool. So that's loose connectors. So what? It has to be more than just loose connectors, because I've tightened a lot of connectors and it didn't fix the problem.
Yeah, exactly. And that's where they're definitely set in place. Like from the PPC standpoint, is the continuity connectors or a plus. Any of the connectors ending with the plus side of things is that they do have a continuity member in there. You can keep your continual ground going from the port to the nut through the cable, which is a great thing. We always still encourage the tightening of the connector. The next most common one is actually in the prep side of things. So jumping from the end install back to the basics of it. So the number one thing there we actually see is actually too long of a center conductor. So sometimes people may either use a prep tool without a stopper on the end, or remove that stopper to make sure they can get an adequately long center conductor. And then after installing on the connector, we'll either leave that center connector long, maybe kind of eyeball it, cut it to length. And many people might think, if anything, it's long, it's going to go into that port and hit that contact. Yeah, absolutely. But then the damage there is actually it can bottom out and essentially buckle that center connector and permanently flare open the contacts in there. So I know John mentioned before the risk there once you get the clamshell or the duckbill contacts there. If you permanently flare open one of those, next time a tech goes through with it could be a perfectly prepped cable and connector, they're going to install it, and you're actually going to have a gap there, so you won't get that constant contact. All from
what is typical center conductor past the flush with the S connector? Is it should be an eighth of an inch?
Yeah, so and that's another very common measure. Is a lot of techs will say, is it the height of a coin? Is it a visible thing right there? And I usually go back to essentially just emphasis on the initial prep. So when you prep the connector, we usually say go with a quarter prep, so 3/4 inch measurements there. So a 1/4 inch for your center conductor, 1/4 inch for your foil electric, and a 1/4 inch for the braid being folded back. So the spec, I believe SCTE is, I think, a 1/4 inch to 325 or something along those lines. So you definitely can eyeball it after that. But the risk standpoint there is just making sure your dielectric is flush with the post, and then you can get a few variables added into it. So when that question comes up, I usually circle back to just the emphasis on the initial prep of the cable.
Yeah, so
and we're talking about 59 and 6, right? Not necessarily mini coax.
Right. So with mini coax, it should be along those same lines of length, I believe. I know from our connector standpoint, we do have a basket that will receive that center connector, and then that will drive a pin internally, move that pin within the connector. So we'll still utilize those same dimensions. Same thing on the 11s as well. But if you did have a full feed through, then that could possibly change.
Okay.
Yeah, so you mentioned like the quarter. If you're using a standard prep tool to strip a piece of coax cable, whether it's 59, 6, or 11, that's going to do that for you, right?
Correct.
I still see some guys out there with just strippers or whatever, not a common piece of stripping equipment that has like the dual razor blades and stuff inside. What's your recommendation from that? Kind of getting off connectors a little bit, but I think the prep is important as a connector.
Absolutely. Yeah. So for that, and we do distribute prep tools, and that's your traditional prep tool with the plastic housing of 2 blades. Those inserts, those are fixed blades. And that's great from the standpoint of not only fixing the kind of the axial length to get those quarter, but also for fixing your height to make sure you don't cut too deep and score a center conductor. Maybe you don't cut the jacket enough. You could cut braid. So that's what we really recommend is a really nice fixed blade, and replace those whenever they get dull. Depending on usage, usually in the 3 to 6 month range is ideal. Sometimes can stretch those a little bit longer, but like anything, a nice sharp blade is always great to have.
Yeah. So we had someone write in on a podcast I did not too long ago about scoring the center conductor and sheath currents.
Yeah.
So from like an RF standpoint, RF guys kind of understand sheath currents, but is that something to be concerned about with connectors and high signal powers from cable modems?
Yeah, absolutely, and that's a great question on that standpoint. Is if a blade were to cut too deeply and you go past the copper portion of a center conductor being copper clad steel, if you cut through that, I usually kind of use the analogy of you're almost kind of cutting off the highway. There is that signal is going to travel along that copper of the center conductor or the outermost diameter portion of it, and scoring that center conductor can potentially damage or cut your signal there, especially
So
on
it's not, we
frequency.
probably need to like reword that, Brady. It's not sheath current, it's skin effect.
Skin
The
effect.
skin
My
effect,
apologies. Yes.
right? And,
Yeah.
yeah, so the skin effect, we know the higher frequencies travel closer to the edge of the cable, right?
Yep.
Correct. Yep.
Yeah, and I think that's. I mean, I think it's important to bring that up because unless you really understand or have been exposed to like RF signals before and understand how they travel as the skin effect, so they're riding on the very outside of that piece of coax that or not the coax but the center conductor, that little tiny piece of coax or center conductor, that piece of copper running through. So people don't realize when they're nicking that, they're actually causing, and put the connector on, they're actually causing themselves issues later on that they might not realize. They could end up visiting that subscriber's house, and it's really hard to see once that connector's put on that there's a nick in that piece of copper, a little center copper there, and those cause micro reflections, and so it's like an unintended consequence. You don't realize you're doing it, but yeah, it could cause revisits back to that house. If you're using proactive network maintenance, P&M, those are going to cause those houses to maybe be yellow or even red in color. And now you're back revisiting and trying to understand, why isn't the modem having issues, and why am I seeing reflections?
Absolutely, yeah, and that's one of those things where if you think about, if you're ever questioning, is that a score there or anything, is just cut a little bit back on the cable and re-prep it from there. Invest another 30 seconds or so in prep, saves you that trouble call or re-truck roll like you mentioned.
The reason why I brought up the mini coax is when Cisco started first utilizing mini coax MCX connectors, and I asked you about the dimensions of the dielectric and the center conductor, and we had prepped prefabricated cables like jumper cables with MCX on one end and F connectors on the other end. So the customer said, well, I don't need 3 meters. Let's cut it down to 1 meter so I don't have to bind it up and it fits in the end, whatever. I said, well, I'm happy and I'm fine with you prepping your own F connector side, but I didn't want customers messing with the MCX side because our original MCX design was 1/8, 1/4, which meant it was 1/8 of dielectric exposed and then 1/4 for the center conductor. So there's two problems here with mini coax. One, it's so small, the center conductor is not copper clad steel. The center conductor is solid copper. So you really should treat mini coax like fiber because you really could bend it a bunch of times and potentially break the center conductor. Or you might just step on it and crush it and change the impedance where you crush the cable. The other one would be if you try to make your own MCX connector, termination if you will, pulling back the dielectric 1/8 of an inch was super tough. And sometimes the outer sheath braid would wrap around the center conductor and you wouldn't realize it because your stripping tool was dull. So, I mean, it took a little bit more diligence, I guess you could say, to make sure you made the MCX properly. Now, we redesigned some of our MCX that now we can accept a different MCX connector. So we can do it 1/4, 1/4, so it makes it easier. But yeah, MCX takes a little bit more diligence, I guess, than, say, an F connector, putting on an F connector.
Yeah, definitely. Especially when you get down to those small sizes, is all those little measurements and paying attention to the craft is definitely important.
Okay, so we've talked about loose connectors. We've talked about cutting the actual coax itself for the center conductor on there. So what other things are we looking at?
Yeah, like actually perfectly transitioning, and like John just mentioned, is the braid removed during the prep of that. So we've seen sometimes if you have a dull blade, is that will actually wrap the braid. It won't cut it. It'll wrap it around the center conductor. And you're essentially shorting out your signal when that happens. So if you envisioned when you prep a cable, you have your center conductor and then your braid and then your jacket. But if you had one of those strands of the braid wire the same length as the center conductor, but then just wrapped around really short, pushed up back against the dielectric, is, you could possibly miss that. What that happens, then tying back to the skin effect, is you have that signal traveling along the center conductor. You can short that out and go right to the braid right from there, and essentially kind of mess with that signal a bit. So, keeping back with the sharp fixed blade, and that could potentially mitigate that. But just when you're finished prepping, take a quick look and make sure all that braid is clean, folded back. And on the flip side of that is if you had a long piece of braid folded back, goes along the jacket, it actually is a potential of a leak path if you have an outdoor connector for any moisture able to go in there. So when that connector were to compress and try and seal between the connector and the jacket, is you have some braid strands sticking out the back, allows for water ingress to get right into there. And then that's going to, of course, corrode within the cable and, potentially get into the port that your connector is attached to.
I've even seen people pull the braid back and trim it up like they're giving it a haircut.
Yeah.
Like, that's kind of changing the mechanical advantage of the connector and how you crimp it or how you compress it on, because you're losing some of that hardware that's supposed to be there. Mm-hmm. And what about the aluminum foil? Have you seen people like actually pull the foil back with the braid?
So with ours, it's pretty well, in what I've seen for most cable in the U.S. Internationally, it does have some lower bonding forces, but with the innermost layer of foil bonded to the dielectric, usually it's pretty darn tough to get that off of that. It shouldn't be able to be removed with a fingernail or anything. However, if you are doing a tri-shield or a quad shield, and that second outer layer of foil, if that's not properly removed, that can definitely make it very difficult to install the connector properly. So that one, you want to remove that foil entirely right up to the jacket. So yeah, we have seen some people, try and fold it back just with the braid there. And then once we, kind of walk them through that and explain, you can just remove that, the tape piece of that. Of course, the connector goes on a bit easier then.
Cool. And you made one comment about if the braid is sticking out below the connector, that will allow water to leak up in. That's actually something I've not heard of before. So what's your recommendation there? Just make sure that there's no braid sticking out. But how do you know if the braid's like kind of right on the edge of the connector? That seems like it could be a condition. It's hard to see. But now you've left ingress going up into the connector. What are your recommendations there?
Yeah. So same kind of sticking with the same theme is going back to that first prep, is just making sure that after the blade preps that cable, is that the braid is going essentially right straight up to the dielectric there. So you have a 1/4 inch of braid before you fold that back. And then if you do have any longer braid pieces, you can either, cut the cable and re-prep, or, give it a little bit of a haircut.
Yeah.
Go through there and make sure you're set prior to installing the connector on.
Cool. That's an interesting one there, because corrosion is one of the things we talk about frequently that happens on a lot of different devices that will definitely cause micro reflections. But obviously, if you get water ingressing it up into that underside of the connector, you're going to get corrosion there, and then you're going to get micro reflections. So that's a good piece of information. Thank you.
Yeah. And another thing in that same area is the next point is the proper compression of the connector, and making sure you're using the correct tools with those. So when you want to actually make sure the compression is complete, you're getting a good seal, not only from a moisture standpoint but also from a retention standpoint. You want to make sure that the cable is not going to just yank out of the connector, and you're still meeting all of the SCTE specs of those retentions. It really goes back to just making sure you have a good compression tool. Our one in the Tools for Life program will use a straight kind of a lever action to make sure that it drives it and compresses it properly. And in those ones, it's also making sure you have the correct compression length. So you have the traditional and the XL lengths, or 18 and 21 millimeters, I believe it is. Making sure that you're not swapping that with the tool. So if you were to have a short connector using a XL compression, It's not actually going to compress the connector entirely, and that'll leave the ability for moisture to get in, as well as the cable to be pulled out easily. And then on the opposite end, if you are using a shorter compression tool but a longer connector, and you're someone who's very determined to get that full compression of the tool, you could risk damaging the connector that you're installing.
So I have one compression tool, and I use that for all the. I use that for every connector that I have.
Yeah.
How do you know what compression tool goes with what size connector then? Because I'm kind of understanding you're saying that there should be certain compression tools that go with certain types of connectors to make sure it's always compressed right. Is that what you're saying?
Yeah. So there are what we've seen is it's regional. So usually within a very large region of the U.S., one will prefer longer XL compression lengths. Other regions may prefer the shorter of that. From the PPC side, our XL connectors that will actually say XL on the little black plastic body, so you can just look at that connector and know, yes, this is the XL length. And also they're designed well enough to where you should have a pretty good understanding of if you go to compress that, something doesn't really feel right or look right, or if you're using a larger compression length or a shorter connector, you might see a gap there, and there's an indicator where you kind of are able to visually see that. And likewise on all the other different connectors out there that are available is usually you can get a pretty good feel for that. And as well as the information on the bag should provide what that the length of the connector is, or denote if it is a shorter length or a longer length.
All right. John, it sounds like you're going to say something there.
Yeah, I'm going to laugh at you, Brady.
Because I just have one.
So the big thing coming up now, I think, would be extended spectrum DOCSIS, going to higher frequencies. I assume most of these connectors are good to way past 3 gigahertz. Richard, what's your thoughts on this?
Yeah, so our official stance is, right out to that 3 gig standpoint. Of course, with we've got a great in-house test lab here. We've run them out past that. For right now, is what we're really seeing is customers calling just for that 3 gig standpoint. So that's what we will go to. But it's definitely a great point of where the future is going, and making sure these will last beyond that 3 gig standpoint.
Yeah, it's
and with, even though most people are worried about higher frequency, problems in coax and cable can be very frequency dependent. Do you see any return loss or problems at different frequencies we wouldn't think of? We're trying to maybe push the 204 megahertz on the upstream. I assume a passive connector, if done with good craftsmanship, should have no problems from DC 0 all the way up past 3 gigahertz. Right.
Yeah, and that's where as long as you're doing all of the great proper initial steps, is as this progresses forward, good connector, good cable, great craft is you should be good solid connection going through there, and performance wise as well.
And I know we're talking about connectors mostly, but you deal with the cable side as well.
Yes. Yep.
Not just okay. And are you seeing anything in the industry pushing more bigger coax, like more RG11, since we're going to 1.2 gig, or maybe 1.719, 1.8 gig, or maybe 3 gig? Have you seen designs or anything going with bigger coax?
Yeah, so and with that is we've with the product offerings, we got the 59 mini 6 and the 11 series. Is we have seen a lot of increased usage on the 11 side. A lot of that is the emphasis with green fields and doing a lot of pedestals, a lot of new burial routes of those ones. From a performance standpoint, I haven't seen anything too dramatically different yet. I know the 1.2 gig standpoint, that was, I think, over the past few months was the official release of that one, and we are looking at that. But yeah, so 11 series is still definitely going strong and well and used out in the field.
Obviously for frequency and length, right?
Yeah, length
okay.
of the run. Yeah.
Okay.
Yeah.
All right. So, Rich, are there other things that from the connector standpoint we should be concerned about?
Yeah, definitely. And then kind of to tie to those long runs or those outdoor usage is when for those aerial runs using a messenger cable is the proper separation of the messenger from the cable itself is a common one. So the best case for that is as usually tear down and towards you. So if you were to separate that, it's going to keep that material between the messenger and the coax cable. And the worst case there is doing almost like a zipper or a Y formation. And that right there, if you think of it, it's essentially stretching that material. And the worst case is if a cable were to be, maybe it's an older cable that's been in the field and from a long time ago, it wasn't as UV resistant. It's a little more of a brittle jacket. You could actually rip that jacket away, and then all your careful prep of making sure there wasn't any braid out the back of the connector and making sure it was properly compressed. Well, you'll actually have a tear in the jacket itself from the improper removal of the messenger from that. So that's one we will commonly see. Usually, it's on older cables that weren't as strongly resilient to the UV exposure. And tech were just to cut off the old connector, install a new one. You can see that sometimes. So it's something we always make sure that you properly tear it essentially down and towards the cable side of things.
Yeah. So when you say down and towards, you're saying pull it back, kind of as close as you can to the cable. You're kind of like wrapping it back rather than pulling it away.
Yeah, exactly.
Okay.
Yep. Once you go with the cable as pulling away, you don't want to stretch that out and kind of like the old wishbone of pulling it and see which end wins.
Right.
This you ensure that it's continuous and you're not ripping any jacket material that you don't want to rip from there.
Okay, makes sense.
Yeah. And then the next one is actually kind of going back internally to the cable is dielectric damage and making sure have a nice clean impedance of 75 ohms going through. Is that sometimes if someone's concerned about fitting the dielectric through the center post of a connector, they might pinch the dielectric a little bit, thinking it will funnel itself in better there, and that can actually ruin like John mentioned before, the impedance side of things of that cable is if you have the dielectric shape and diameter damaged throughout that.
So here you're just saying you're pushing the dielectric through the connector now, too far through the connector, rather than flush with the front face of the connector that's on there, right?
Yeah. Also that, and then also the diameter of that dielectric or that foam. If someone were to pinch that and shrink that diameter, then yeah.
And what would be the reason that they're pinching it and shrinking it?
Yeah, so some people say if they aren't able to easily center it up and line it in, they might think, oh, it's a little bit of a easier, almost a funnel or a taper right there. That one's a little bit less common, but we've certainly seen it. Or if you had a prep tool that maybe didn't have a proper stopping and you push too hard, could also compress on there. Then you also link that to scoring of center connectors, cutting of braid, and other risk factors like that.
Mm-hmm.
Yep.
Yeah. So I've seen the two cases where either the dielectrics push too far through the connector, or the dielectrics recessed in a connector, and both of those cases it seems like they caused grounding issues of some sort, where I see micro reflections at that point.
Yeah, and that's another great one too. Is that especially when they are short of the post, or if they were go too long, some compression tools will kind of push that dielectric back flush with the post when compressing it, but then you are actually leading to a longer center conductor if you think about it that way. Of had your quarter, you push that dielectric back, that quarter inch of center conductor just grew quite a bit longer relative to the dielectric front.
Yep.
And also with that is making sure that any adhesive or leftover dielectric is removed from the center conductor. That can cause an intermittent signal between the center conductor and the internal contacts of the port you're going into. So sometimes if the cable had too much adhesion between the center conductor and the dielectric, you need a little bit of foam left there. We've seen people say, oh, we can just scrape it off with a knife. Of course, definitely don't want to.
That was going to be my question. What's the best way to remove it without scratching that center conductor and impacting the skin effect. John, is that the right one?
Yeah. Yep. Skin
Yeah,
effect,
I said sheath current before. It's skin effect.
Yeah, no, great question there. And our two most common responses are if you can get it off with your fingernail, go with that, or use a plastic credit card and kind of scrape it off from there.
Okay.
Yeah. Of course, you don't want to use anything that can damage it. Copper's naturally very soft, so you could risk damaging it if you use anything harder or metal objects to remove it.
All right.
I've seen where that adhesion, almost like a little glue or whatever, would manifest itself as almost like a 6 dB pad. I'm like, where is this extra 6 dB of modem transmit level coming from? Meaning my modem was transmitting 6 dB higher, and it was acting like an attenuator at certain frequencies, like in the lower end. And maybe it's because the higher frequencies could jump across. I don't know if it had anything to do with higher frequency radiation, how it works, but it was only affecting my lower frequencies. So it was very interesting that something as simple as the dielectric adhesion or that glue was causing this problem.
Yeah, absolutely.
Yeah, I think that just, again, it just reiterates the fact that these, small things that if we do wrong when we're putting our connectors on, create havoc later on. It's really difficult to find.
Yeah. And that's where I always go back to is, just that little bit of prep work and time up front saves you. It's a whole lot shorter than, going back and revisiting the house too. So.
Yep.
Hey, so Richard, you mentioned the not Siamese cable, but the messenger cable. What about drip loops?
Yeah, so essentially when dropping that down and most commonly going to, I'm guessing you're referring to like a ground block mounted to the side of a house doing a drip loop run. Yeah. So when doing that, best practice, of course, use all the proper hardware to fix the cable properly. So use a drop clamp to be able to attach and lash the messenger cable around that. That'll support it. If anything like a branch or something were to drop on that. Then you run that cable down along the side of the house to a ground block, is you want to do the drip loop formation, which is essentially kind of go down, then go back to a curve to take your turn, as opposed to just doing that curve there. And that ensures you don't have any residual water dripping down into that. Now, if you're properly installed and the connector is all there, it should seal properly. This is just another great kind of redundant safety feature when installing that, is to kind of do a loop down and around before going into a ground block.
Would it be a problem to do a complete circular instead of an actual loop? Some people might just put it in a roll.
Okay. Yeah. Yeah. So I usually say, if you kind of go down, you go from 12 to 6, and then back from 6 to 9 to 12, and out at 3. Kind of thing from that rotation of that. But yeah, we have seen some people do that same just loop right in there. Of course, some situations you have to make it work from there, but the ideal state is to do that rotation.
Now, since you're on the cable side and the connector side, have you seen any usage of the clamp-on ferrites to stop sheath currents and hum and noise?
No, so essentially kind of clamshelling around the exterior of the cable.
Correct. There was a couple of vendors making, I think Signal Vision or one of those guys was making a clamp-on ferrite. The idea would be the same as, taking coax and making a common mode choke, where you can roll the coax up in maybe 7 turns, about the size of a coffee can. According to Ron Hraddick, and you can basically make an induction type of field. I think that's what it would be. That could be part of the right-hand rule. But then they came out with this little ferrite that would clamp around the coax itself to help stop any type of sheath current, which could cause maybe hum, some type of hum modulation or ground loops.
Yeah. No, I haven't seen too much of that put out in the field. I know within our we have another portion of PPC doing the entry units and the amplifiers that has created some products mostly linked around more of the kind of set-top box and modem realm over there to help with that and create a similar feature. But in terms of the 6 series cable or especially running outdoors, I haven't seen too many of those.
Okay.
Yeah. And there very well could be just haven't seen them. Yeah.
That's good.
Yeah, no, I've definitely heard of the loops before, but I don't see them used very often. And I think on the hum mod side, that was something that we were doing probably earlier before digital channels became as popular, John. But I don't see people doing the loops that much anymore. So I think though, if you're above the equator, you have to do the loops going to the right, and if you're below the equator, you have to do them to the left. Otherwise, they just don't work. Yeah.
The Coaxial effect. The Coaxial effect always kicks in.
Reverses your signal or something like that.
Exactly.
Yeah.
The electrons just get confused when they're going. Yeah. So all right. Any other items, Rich, that you want to bestow upon us?
Yeah, keeping in that kind of same realm of the the external use and the drip loop side of things is making sure you're properly sealing the connector. So if you're using a connector outdoors, using a proper weather seal there, whether it's a integrated weather seal into the connector and it's built in, so you can just install it traditionally, or if it's a external weather boot or fitting there, is making sure that is installed onto the port. Making sure the port is a outdoor port, and the way you can tell that is you'll have a smooth sealing surface there with adequate amount of room for the seal to sit. An indoor port will traditionally just have the threads go all the way back to the hex or whatever the end point of that port is. So you always want to make sure you have the correct port with the sealing surface. Then be able to install a weather seal or a boot onto that, or use a connector with an integrated weather seal. Some of our Aquatite ones, for example. And then when you have that, kind of the common sense part of make sure it's on the right direction. Most of all the weather seals in the industry do have a directional feature. I know some are kind of a tapered cone design. Ours are 2 different diameters, so the larger diameter does go towards the connector side of things. So just making sure that's all there. And then making sure, of course, your connector is fully threaded on, torqued, tightened, and it does lock up. Some people might think the threads are able to seal, or if you torque it even harder, that's going to seal better. But that's where proper port and weather seal will do the best job to keep out all of the moisture from the front end of the connector.
Yeah. So are there studies that have been done to show how well that weather seal works? And the only reason I'm asking is I see so many techs complain about the weather seal and then chuck it because they don't want to use it. And I'm wondering, what is the value of that weather seal?
Absolutely. Yeah. So our test that we'll do to qualify essentially a watertight solution is internally we'll do a red dye test or a moisture ingress, where essentially we'll create a 2-foot long jumper with connectors on each end, and those will be fully sealed off, making sure that the back end is sealed with no braid or anything sticking out, making sure the front end is sealed with either a external weather seal or a integrated weather seal. Each end of that jumper goes into a vat of essentially red dyed solution or liquid. Then that goes into a temp chamber that will actually temp cycle from hot to cold for 5 days. That then expand and contracts your material. A lot of the jackets being PVC or PE, very susceptible to that expansion and contraction of temperatures. Then we'll take those out after 5 days, let them sit, dry, and in anything that was there within the moisture standpoint, the water would evaporate, but the red dye will permanently dye anything in there, especially alongside of the braid. If it were to essentially create a suck up effect, where if moisture does get in, you can actually see it start to travel up and through the rest of the cable. So then we'll take those out, break them apart, take apart the connectors, cut open the jacket, and truly test and verify that the weather seals, both integrated and non-integrated, do protect it from any moisture ingress.
Okay. So while we're talking about moisture ingress, I'll have to say one of the things that I see very frequently in like proactive network maintenance is any splices in a drop, whether it's aerial or buried, Those seem to
Yeah.
be ones that inevitably come up as showing homes as having, micro reflections and stuff. Do you have recommendations in actually, is there a way to make a splice in a drop, whether it's aerial buried, that is actually going to last for an extended period of time?
Yeah, yeah, and that's definitely, I think, kind of just using all the core principles we've been talking about is, the good cable side of things, good connectors, good F81 or barrel, connecting those two portions, and with the proper prep and everything, it should adequately last. Obviously, a true straight run or home run, there's the best possible solutions, but if you're properly installing everything there, you should be able to achieve, your desired level of performance.
Okay.
And same thing on the ceiling side from a weather standpoint is everything should, be locked in tight there as well.
All right.
And some of those we'll actually see, we actually do have both indoor and outdoor ones there, kind of like I referenced before. Of your outdoor, you'll have a nice ceiling surface for either the weather shield to go onto, whereas the indoor ones will be fully threaded. And the reason there is you actually kind of a dual use for the indoor. Not only does it not need that ceiling surface, but you can use it in a wall plate. So that allows for that to be affixed within the wall plate. You, of course, have the thickness of the wall plate there. You need to tighten it onto that. So that's where those additional threads come into play.
Okay.
Yeah. And I think that's, the last thing on the list was, short center conductor. Pretty straightforward on that one of, center conductor is too short, won't be able to go into the port or the device you're looking to connect to, and you're essentially going to have, no signal going through. But
Right, because it's just not going to be touching to what it's supposed to be connecting with. So you're losing that. Yeah, obviously.
Yeah.
It seemed like we were focusing most of this talk on F connectors and drop cable. Yeah. Anything specific to hardline cable?
Yeah, definitely. So on that side of things is when you're doing, especially like QR, when you have to worry about the jacket there, is making sure that you're not cutting any bit of the jacket. I think the most common one you want to see that, or we want to check for there, is if any heat shrink is being used and you're replacing that connector or checking that connection, is during the removal of that heat shrink, is that you don't score anything from both a environmental and even a integrity of the cable standpoint. Is if you really dug in there, you could score some of that cable. You can really damage the outer conductor and potentially risk some other things there. That's one of the little bit more ones we've seen kind of out there. In terms of the prep and everything is same kind of the same theme as the drop connector side of things is making sure that you have a good coring tool. You're not scoring anything. It's nice and centered, whether it's the hand tool or a drill. Making sure you have a good new guide sleeve on the front there. We've seen sometimes if you have a worn out guide sleeve that will fit over the outer sheath or outer conductor of the hardline cable, that lets that travel a little bit, and then the tool doesn't line up quite exactly right. So it allows for the rest of the drill to go off center, especially with a cordless drill. Everything's going a lot more quickly with that worn out guide sleeve, and then you could either score parts of the outer conductor or even get into the center conductor, other possible damage areas. That's a simple one of just kind of paying attention and see how the prep tool fits over the cable, and replacing a little plastic part that's maybe $1 or $2 each time.
Yeah, so from my experience, let me give you an example. We have a new node called the iNode, intelligent node, where it uses some type of no seizure screw. Mm-hmm. So basically like a Chinese finger puzzle, right? So the center conductor of the pin can go in and just kind of wrap around 360-degree connection. On the housing itself of the node, there are guides to tell how long to cut the pin. So if people don't know like how long to cut the pin, obviously they can go too far in and actually ground out somewhere. If they're too short, then they're not going to get a good connection. But I've also seen where people cut the pin with maybe a dull pair of dikes or wire cutters, and it kind of smashes out the end of the pin instead of being nice and round. So if it kind of smashes the end and you try to shove it in there, it might not go in very easily. So I've seen that, as a concern as well. And then to take that and know that our older line extenders still had seizure screws. So I could have a contractor thinking that all the line extenders are the same as the node, and they're not. Meaning, if they take the pin and try to shove it into the line extender without pulling out the seizure screw, then obviously it's just going to bind up, Yeah. So it's kind of like understanding, does the housing accept seizure screws or seizure lifts, and how long to cut the pin, and so it's not just a connector; it's also attaching it to the devices themselves.
Yeah, definitely. That's another great point.
All right, guys.
One more thing. Do you deal with the newer Node +0 designs and centralized powering? Have you dealt anything with like the power feeder 625 cable? Anything with like the you know what I'm talking about?
Yeah, I do. So personally, I haven't delved in that too much, but I'm still familiar with it. We have done some things here, but the power feeder cable, which is essentially a big solid copper center conductor, able to feed that through and power those nodes.
Okay.
So, all right, guys, we're coming up to the top of the hour here. I would give you an opportunity. John, I think you're going to be coming to Cable Tech Expo, right?
Yep. I guess a plug for one of the workshops I'm in. I'm moderating a workshop with two gentlemen from Aris CommScope, John Ohm and Tom Clunan. And ours is Tuesday, I believe, at maybe 12 o'clock. We're doing a workshop on how to get to 10G, meaning 10 gigabits per second. I tell people, I'm like, we keep using this terminology loosely, like 5G. Does it mean fifth generation, 5 gigabit per second, or 5 gigahertz? What does it mean? We keep throwing out these words in this nomenclature. It's all semantics, I guess, but it isn't. So, now 10G is where we're trying to go, but 10G in cable means 10 gigabit per second. Mm-hmm. We're not talking 10 gigahertz, right? We're talking 10 gigabit per second. But that's what my workshop's going to be on, is talking about how do we just increase more speed? How do we get more speed through DOCSIS?
Cool. I'll attend, and I recommend everyone else does. Rich, how about I know PPC is going to be at Expo. Anything you want to promote?
Yeah, absolutely. Yeah, so we'll have our PPC booth there, and all of the different drop connectors, cable, and everything we talked about, as well as our other full product portfolio offerings, even the fiber side of things. We'll have all at our booth there at Expo. So stop on by and check them out.
All right, sounds great. Guys, I want to thank both of you, John and Rich, for your time today. This was a really good episode. I enjoyed all the input. Our next episode is episode 52 on October 8th. It's going to be an SCTE EXPO Recap. So we do our best every week or every month to try to bring our audience great technical content. You can catch us on YouTube or on podcasts or on volpefirm.com/events. Please do click like if you like what you're seeing. Click on the little bell on YouTube or subscribe to the podcast channel if you like what you see here. Thanks so much for being here, and we will see everyone next month. So thanks again, and so long.